Hi everyone, welcome to 7.5, solving two-step equations. Tonight we are doing a flipped classroom, so you are listening to me at home so that we can do an activity tomorrow in class. But we have been talking about how to answer and solve one-step equations, but today we're going to talk about how to do it whenever you have two-step equations. There are some rules that you're going to need to know whenever you are doing two-step equations. The first thing I want you to write in your notes, and if you have a red pen, go ahead and slip it in with a red pen. I want you to make sure before you do anything else, the first thing you're going to want to do is add or subtract. Then, keyword here is then, that means next time, after you add or subtract, you are going to multiply or divide. So in this case, the order definitely matters. First, add or subtract, then multiply or divide. Continue to write this with your red pen if you have a red pen with you. You never want to move the number that is attached or next to the variable first. You've got to get rid of everything else, and then the number that is attached to the variable will be moved last. So if you see this example, 2x plus 5 equals, let's say 15. You want to always get rid of the thing that's not attached to the variable. So you can see here the 5 is not attached to the variable, so we would get rid of the 5 first, then you would get rid of the number that is attached to the variable after that. We'll go through some examples here in just a minute. Our first example is asking us to solve this equation and then check our solution. If you look here, you can see, once again, my goal every time is to get the variable by itself. So I want x to be alone, but there's two things that are not allowing x to be by itself. The first thing is this 5 that's right here, and the next thing is this minus 6. So I have to get rid of two things, which is why it's called a two-step equation. So if you look at the notes that we just did, at the very beginning it said to add or subtract first. And then that key point that I said was never move the number that's attached to the variable first. So out of those two, you've got to see what is attached to the variable. Is the 5 attached to the variable, or is the minus 6 attached to the variable? What do you guys think? The 5 is definitely the one that is attached to the variable. So we've got to get rid of the minus 6 first before I can get rid of that 5 that's attached to the variable. So our steps are still the same. I've got to figure out how to get rid of it, so we're going to do the inverse operation. Inverse just means opposite. So what's the opposite of minus 6? Plus 6. Remember, what I do to one side, I must do to the other side. So this is going to cancel out, and you can see on the left side, I am still left with 5x. Bring down your equal sign, and negative 21 plus 6 is going to be negative 15. Now, this is a two-step problem because x is still not by itself. You can see right here, the 5 is not allowing x to be alone. Remember, when you have a number next to a variable, what does that mean? What does 5x mean? It means 5 times x. So I have to get rid of multiply by 5, and in order to do that, I have to do the opposite, which is divide by 5. These will cancel out, and I'm left with x equals negative 15 divided by 5, which is negative 3. So that's my answer. Now, I want you to double check as you're doing this. Remember, you want to try to keep those equal signs all lined up so that your work looks nice and neat. Next, it asks me to check my solution. You're going to check it the same exact way. Rewrite that original problem that you've got, which says 5x minus 6 equals negative 21. Now all I'm going to do is, instead of that 5, I'm going to erase that 5, or that the x, and put negative 3 instead. So now I know 5 times negative 3 is negative 15, and then, sorry, I'm going to be subtracting 6 equals negative 21. Now I'm working the left side. Negative 15 minus 6 equals negative 21. And then I do see that checks out because that equals negative 21. Okay, so that is how a two-step equation works. All right, example 2. Look at your notes. Once again, we know we have to add or subtract first. So remember, my goal is to get b by itself. As I look at this, there is a number that's attached there, and then there is this minus 7. So I want to get rid of my minus 7 first, because that's add or subtract. And remember, our rule says always leave this one right here that is attached to the variable until the very end, okay? So let's go ahead and get rid of that minus 7. What is the opposite of minus 7? Plus 7. What you do to one side, you must do to the other. Negative 7 and plus 7 will cancel out, and I'm only left with negative 7b on the left side. And then we know that negative 42 plus 7, if you do same sign, add and keep, different sign, which I have here, subtract the numbers and take the sign of the larger number. So that's going to be a negative 35. Now, we still have to get this b all by itself. What is not allowing the b to be alone? Negative 7, but remember you have to tell me whether it's add, subtract, multiply, or divide by negative 7. This right here means negative 7 times b. In order to get rid of a multiply, I have to do the opposite. The opposite of multiply by negative 7 is divide by negative 7. Whatever I do to the left side, I have to do to the right side. So this cancels out, and on the left side, I'm left with plain old b equals. Now on this side, we can see I've got two negatives. Anytime you're dividing by two negative numbers, your answer always turns to a positive. So negative 35 divided by negative 7 is positive 5. Now we've got to check it to see if this is correct or not. So remember, once again, you're going to take your original problem up there and go ahead and just bring this down here. So I've got negative 7b minus 7 equals negative 42. Since I know what the b is here, I'm going to go ahead and get rid of that b, and instead I'll plug in what I figured out my b up here is, which is 5. So let's multiply by 5. Negative 7 times 5 is negative 35 minus 7. And when I do that, I see I have a negative and a negative, same sign, add the numbers and keep the sign. So that would be negative 42 equals negative 42. And it does check out. We're going to continue working a few more examples just like this. So next up I've got, all right, this is what we're going to look at for problem C. 6d minus 9 equals 15. Remember, you never want to move the number that's attached to the variable first. Still, my goal, just like when we had only one-step equations, is to get the variable by itself. So I want d to be alone, on its own side. This is the equal sign, which means this is all to the left and this is all to the right. So we are trying to get rid of everything except for the d on the left-hand side. So the first thing I have to do is add or subtract. For this, I'm going to try to get rid of minus 9. What's the opposite of minus 9? Plus 9. So add 9 to both sides. Remember, you got to be fair. This will cancel out. And on the left side, I am left with 6d. Then 15 plus 9 is going to be 24. Once again, on the left-hand side, I am trying to get d all by itself. What's not allowing d to be alone? The 6, but what about the 6? Multiply by 6. So the opposite of multiply by 6 is divide by 6. I am now left with d equals 4. So that's your answer, but remember I need to check it. So let's come back to the original problem, which said 6 times d minus 9 equals 15. I know what d is now, so I'm going to go ahead and get rid of that. And instead, I will multiply it by 4, since I learned up here that d equals 4. Then I'm going to work from left to right. 24 minus 9 equals 15, and that is true. 24 minus 9 is 15, and that does equal 15. Okay, so now let's go on to the next one. Once again, remember, never move the number that is attached to the variable first. This right here, you can see this is attached to the variable. It's right there in the same thing, c over 3, or c divided by 3. So I'm going to leave that 3 alone first, but in order to get this c by itself, I also have to get rid of plus 13. What's the opposite of plus 13? minus 13. If I minus 13 on the left of the equal sign, I also have to minus 13 on the right of the equal sign. So now these will cancel out, and on the left side, I'm left with c over 3 equals, and then I've got to look at the right side. What is 10 minus 13? 10 minus 13 equals negative 3. Okay, now, divide by 3 is still there. What's the opposite of divide by 3? Multiply by 3. What I do to one side, I must do to the other side. This will cancel out, and then I find out that c equals negative 9. Once again, let's just go ahead and check it. So you're going to bring this down. Instead of c over 3, I'm going to put negative 9 divided by 3 plus 13 equals 10. Now, let's go ahead and work this part. Negative 9 divided by 3 equals negative 3 plus 13, which equals 10. Now, same sign, add and keep, different signs, subtract and take. We know that that equals 10, and 10 equals 10. All right, we're going to go ahead and do 2 more examples just like this. Remember, in our notes up at the top, you hopefully wrote it in a red pen. First thing you want to do is add or subtract, then you want to multiply or divide, and you never want to move the number that's attached to the variable first. This right here is attached to the variable, so I'm going to leave that alone. Once again, my goal is to get the x by itself or the variable by itself. So now the first thing I have to do is add or subtract. This right here told me that I have a negative 10. The opposite of a negative 10, or subtract by 10, would be what? Positive 10 or add 10. If I add 10 to the left side, I have to add 10 to the right side. This will cancel out. Now on the left side, I'm left with x divided by 2. Coming over here to this right side, negative 10 plus 10 equals what? It equals 0. Okay, now once again, my goal is still to get this variable by itself, but divide by 2 will not let me have it be alone right now. So I have to do the opposite of divide by 2, which is multiply by 2. This right here will cancel out, and 0 times 2 is 0. So your answer is x equals 0. Now we want to check it out to see if that's true or not. So let's take the original problem that I have right here, and I'm going to bring this down here. So I've got x over 2, or x divided by 2, minus 10 equals negative 10. Now I know what x is, so I'm going to get rid of this x right here, and instead I will put what I found my answer to be, which is 0, right here. So let's work this out. 0 divided by 2 is 0, minus 10 equals negative 10. Now we learned in one of our properties, anytime you are adding or subtracting by a 0, it just equals itself. That was the identity property. So 0 minus 10 is just negative 10, and negative 10 does equal negative 10, so that did work out. All right, let's do our final problem that we've got like this today. First thing I want you to do is I want you to look on the left side. As you look on this side, I want you to look to see if there's any like terms that you could add together. As I look at that, I can see 2x and 3x are both in the x family, so they are like terms, and then plus 10 is just there by itself. So let's combine our like terms. 2x plus 3x is 5x, and bring down your plus 10 equals 30. Now it looks like a normal two-step equation. Always look at your notes at the beginning. It says add or subtract, then multiply or divide. So I know that I don't want to move the number that's attached to the variable first. This one is attached to the variable first, so I'm going to get rid of the plus 10. What is the opposite of add by 10? Subtract by 10. What I do to one side, I must do to the other. This cancels out. I'm left with 5x on the left side equals, and 30 minus 10 equals what? 20. Remember, your goal is to get x by itself. If I were to split this in half, on the left side, I still have a 5 that goes with that x. Remember, this does not mean to add 5. Instead, that means to multiply by 5. And the opposite of multiply by 5 is to divide by 5. So now we know our answer is x equals 4. This can get a little tricky, so we're going to go ahead and plug in the original problem. 2 instead of 2 times x is going to be 2 times 4 plus 3 times 4 plus 10 equals 30. So let's work this out. First up, 2 times 4 is 8, 3 times 4 is 12, and bring down plus 10. Now you can slip this in your calculator or do it in your head. We know 8 plus 12 is 20, plus 10 more is 30, and that does work out because 30 equals 30. All right, we've only got one problem left on the back of our paper. All right, here's a story problem. It says you have $11 to spend at the store. You spent $5 on chips. How many candy bars can you buy for $2 each? I want you guys to pause the video and try this on your own to see if you can come up with the answer. Okay, as we look at this, it tells us that we have $11 to spend. So I know the total amount I have to spend. It's $11. Next, it tells me I spent $5 on chips. So I know for sure $5 have already been spent. Now it's asking me how many candy bars can you buy for $2 each. So I know that I'm going to buy some candy bars. So let's just imagine that candy bars are represented by an X, okay? But if I'm thinking dollar amounts, how much was a candy bar each? $2. So it's not just going to be plain old X, it's going to be plus 2X because it's worth $2 each. Now I've got a normal algebraic equation, and it's a two-step equation like we've been talking about today. Your whole goal is to get the X by itself. Remember, you cannot move the number that is attached to the variable first. So I've got to get rid of this guy who's all alone by itself. Remember, add or subtract first. So I'm going to subtract to get rid of that 5, and I got to subtract it on both sides. This cancels out. We know that $11 minus 5 equals $6, and then all that's left over here is 2x. Still, my goal is to get this x by itself. So in order to get rid of multiply by 2, I have to divide by 2. And you want to do the same thing to both sides. Now, this might look like it should say $3 just because of what we've worked on, but let's go ahead and look back at our question. It says, how many candy bars can you buy for $2 each? So your answer should be 3 what? 3 candy bars. Okay, you guys did an excellent job listening to our two-step equation video. We'll talk more about this tomorrow in class.